And of course, the landing page for the campaigns. With Yarnit, you can do all of this with a speed you've never seen before. Yarnit can help you launch a campaign at 5x the speed, at just 1/5 the cost. Yarnit, helping marketers supercharge their campaigns with contextual intelligence. Hi there, and welcome to Yarnit, an AI platform that helps marketing teams achieve superior outcomes you could have never imagined. Yarnit knows everything it needs to about your brand, from your products to your guidelines to your customers. Using this, Yarnit can instantly craft a tailored campaign strategy. With a single click, you can unlock a goldmine of AI-powered keyword insights. You can also create and perfect SEO-optimized blogs and make brand-aligned creatives for social media. Now, what if you could promote this content inorganically? You can generate commercially safe campaign creatives and create compliant and high-performing search ads in just 3 clicks. And of course, the landing page for the campaigns. With Yarnit, you can do all of this with a speed you've never seen before. Yarnit can help you launch a campaign at 5x the speed, at just 1/5 the cost. Yarnit, helping marketers supercharge their campaigns with contextual intelligence.
All right. Good evening, good morning, folks. Thanks for joining us in yet another webinar from Yarnit. So we are going to talk about grounding AI content with data using knowledge graphs, and RAG. If you have been following our latest release, we are talking a lot about contextual intelligence and what basically that brings to whole marketing content generation. So if you are somebody who loves or just follows the space of generative AI, or you are building in the space of generative AI, enthusiast about RAG and knowledge graph, or you're a marketeer who have been using our product or different other products and want to know what goes behind the scenes when people talk about getting more context, making AI more accurate. This is the perfect session. What we want to do through the session, of course, we'll talk a lot about knowledge graph, RAG, what's the current systems, what we have been using, and how did we build the best-in-class system, and also the future, right? As in what future holds in this technology, how we are planning to use that technology, and eventually how would our customers, who are eventually enterprise marketeers, would benefit from these techniques. My name is Jyotirmoy, co-founder and CEO at Yarnit. I have two AI, the core pillars of our AI. Abhinav, he's a co-founder. He heads AI stream. I have Megha with me. Megha is the director of AI at Yarnit. Both of them have been have been spending a lot of time doing R&D, especially in the knowledge graph and the RAG stream. And a lot of their hard work has certainly gone into what you see in the latest release that we did. Without me doing a lot of talking, I would rather leave it to the people who are the best people to speak about it. Abhinav, why don't you take over and take us through the session? Of course, I'll come back and bug you with a few questions. Ask you about what's your what is that you folks are planning next? What is cooking in our kitchen? Yeah. All right. Take it over.
Oh, thank you so much, JD. Hello, how are you? Hi, Megha. Hello, everybody. Thank you so much for joining this session. We are Yarnit, and at Yarnit, we really focus on contextualizing AI, what we call as contextual intelligence. We'll talk about what that means. Uh, AI is everywhere today. We all know how AI works, maybe, or what it can be used for. There are tons of material out there that will tell you, oh, everything can be done using AI. We focus on generating quality marketing content using AI. So let's not talk about what AI can and cannot do, but let's just focus on what are the expectations out of AI, and we'll also discuss how the reality matches up to that. And there are essentially three ways in which I look at what to expect out of AI. We expect the AI to be comprehensive. What I mean by that is we expect the AI to know everything about the world, about me, about my company, everything. We expect AI to be current. It needs to know what is happening now. It needs to respond to events that are happening now. And finally, we want AI to be correct. We want it to be accurate, but the reality is slightly far from it. We know that AI models, AI applications have knowledge limitations. They have knowledge limitation in terms of the data that they have been trained on. So if you go and ask an AI about Abhinav Kimothi, chances are they won't know because it might not have been trained on that particular data. We know that with AI models, there is a knowledge cutoff date. They have been trained uh, up to a point in time. So if you ask about the weather in Bangalore today, chances are that an AI will not be able to answer that. Or not chances, but I can be certain that an AI model alone cannot answer that. And finally, this is a problem that we all know. There is a tendency of AI models to lie with confidence, also what we call hallucinations. So, what does this mean in our context, in the context of content marketing or marketing content generation? What it means is that if I use vanilla AI, the content that it will produce will be quite generic. It will not be accurate, and therefore it'll lead to no efficiency gain. My copywriter, my team can do a better job than AI can do. There'll be a lot of reworks that I will require to do before putting out the final content in the market. But there is a solution to all of this. The solution to all of this is more information. Turns out that AI models, large language models, are very adept at incorporating the information that has been provided to them. What can this information be? This information can be our own proprietary company data. It can be the search engine results telling us what is happening now. It can be trend databases, syndicated research sources, which tell you factual information. So when you give factual information to LLMs, then what they generate is content that is on point, which is accurate and true, which is on trend, knows about what is happening uh, in the world. And of course, it is personalized. I can personalize the content to how I need it. So it talks in my language, in my tone, in my vocabulary. So that is the context that I wanted to start with, the expectations and the reality, and how we bridge the gap between the two. With that, let's jump into the agenda of today's webinar. Today, we will start with a demonstration of how contextual intelligence comes alive in Yarnit. We'll show you the knowledge hub and the context booster in action. Generally, demos are done towards the end, but we thought it would be a better way to start with a demo and then talk about how it happens. Talking about how it happens, we'll then jump into the fundamentals of the technique behind contextual AI, which is retrieval augmented generation. We'll talk about the fundamentals of RAG, and then we'll move on to how Yarnit utilizes RAG and associated techniques to really bring alive the context. With that, let's just get started. And what I'll do is I will hand over the stage to Megha, who will start sharing her screen and start talking about how contextual AI comes alive in Yarnit. So, Megha, over to you.
Thank you, Abhinav. I'll just share my screen. Give me a second. Is my screen visible?
I can see it. I hope
Yes, you can.
everybody else can.
Yeah. So this is the Yarnit brand hub. This is where everything brand in Yarnit resides. We have the brand personality, the brand voice, and what we're interested in today, which is the knowledge hub, right? So this is where all your company assets, all the information regarding your organization or your brand is stored. So right now I'm looking at the brand hub for Yarnit. As you can see, we have a couple of assets that we have already populated it with. So these are the different knowledge information or the knowledge cards that we have saved for Yarnit. So I'll show you how you can create a knowledge card for yourself on Yarnit. So say you click on the knowledge card. So right now we let you create a knowledge card from a URL or a document. So I put in a URL here. What Yarnit does is it goes to this particular page or the document. It understands the information that is there. It passes out the information that is not relevant to the major content, and then it does a form of intelligent chunking. So we use multiple techniques for chunking, and it creates logical chunks that give you the best information, or the most information, most relevant information that is available in this particular document. All of this information is then converted into embeddings, stored into vector databases and graph databases, more of which Abhinav will talk about. But this is where all the knowledge, or how this is how you give Yarnit knowledge about your brand or your organization. So we'll give it a couple of minutes to create, to run through that process. A couple of seconds, actually. Sorry. Yeah. So as you can see, uh, this process is done. So this is the document that we were reading, or we were trying to read. So as you can see, it creates a summary, and then it also creates intelligent logical chunks of the data that is available. It is able to remove all the irrelevant information that is there. So this is how the Yarnit knowledge hub is structured. Now, the next thing that we want to see is, how do I use this information that is there to create you know content that is contextual, that's relevant and accurate for us. So I'll take an example, and I'll create a blog. So I click on a blog, and yeah, so the blog topic that I'm interested in creating content around is, how can marketers, sorry, how can marketers use Yarnit to supercharge their content creation, their content with responsible AI, right? So we talk about responsible AI in Yarnit. So how can marketers use Yarnit to supercharge their content? So this is the topic that I'm interested in. I add content instructions, so I can save my content instructions. So I pull up content instructions that I already have. So this tells Yarnit how I want my content to be structured. And now the next step, how do we bring in all this contextual information that we have? So we have something called the context booster on Yarnit. When you click on explore, what it does is it goes through the different databases where we have stored your data. It does a hybrid search, returns these results, it returns results, re-ranks them, and gives you the most relevant results that you can use to create the content. So here I'm interested in seeing how Yarnit is, differentiating how you can use Yarnit to transform your content. Also, I'm interested in how Yarnit defines responsible AI. So I use this information, I select this information, and I click on generate blog. So what Yarnit does under the hood is it understands the topic that you have given. It understands from the content brief how you want your content to be structured. And it also looks at the different knowledge nuggets or the knowledge chunks that you have selected, and augments the prompt that we give the LLM. And it takes all of this information together to generate a blog that is relevant to the content that you want to create, that has accurate results, and that is contextual to the information that you have provided. So the blog that you have provided is not generic, but it is very contextual to the information that Yarnit has. Yes, we'll give it a couple of seconds to generate the blog.
So Megha, what we did we searched through a lot of information that is present in the knowledge hub, right?
Yeah.
About responsible AI, about Yarnit's role in digital content transformation, and then whatever we felt like selecting, we selected those. But what I want to understand is, how do we know that that is the most relevant information? You talked something about re-ranking. Can you
Yes.
tell us what does re-ranking do?
So, we get relevant information from multiple sources. So, when you get relevant information from multiple sources, we need a way to order these results, right, in a way that makes sense or that is most relevant to the content that you're creating. So, what we do is we use different techniques to reorder these results that come from different sources in a way that tells you what is that prioritizes the information that's most relevant for you. Also, something else that I forgot to mention is, if you don't have, say you want to create content that is not a part of your internal databases, we also have a way of connecting to external sources, where we hit syndicated sources and other search engine results to give you information that you can use and choose to create your content. So this is a blog that Yarnit was able to write, and as you can see, it has also included the information about Yarnit that we had selected as a part of the knowledge nuggets.
So great. So all this information that we can see on this blog is not randomly generated by a language model, but it is actually rooted in the information that we know to be true and accurate, right?
Yes.
And also because we have the brand and all set up, whatever language it is using, whatever information it is using, is in the
Yeah.
style and tonality of the brand that it is generating content from.
Yeah, so it's very much aligned
Fantastic.
to the brand voice that you set up. It also has an intelligence or an understanding of the brand that you have. So all of that information is included while we generate the content. So in addition to uh, the nuggets that are there, all the brand intelligence that you set up on Yarnit is also included or is also in memory while the content is getting generated.
Right.
Yeah, yeah. I think that's the demo.
And
So
that is
back to
what is
you.
contextual intelligence, right? When you build in context into AI. Fantastic.
Yeah, back to you, Abhinav.
All right. Thank you so much, Megha, for that demo. We just want to give you a flavor of what it is that we are talking about, so that now what we can do is take everybody through how it is done, or what is the technology or technique that is powering this thing that I keep on repeating, which is contextual intelligence. Let me share my screen again, and we'll continue from where we left. I hope my screen is visible. Yeah, Megha, can you see my screen?
It's visible, yeah.
Yeah.
Yes, Abhinav,
All
your screen is
right.
visible.
All this talk about contextual intelligence, routing the generation through from an AI into context or information that we need, that we know is true and accurate. How is it done? It is done through a novel technique called retrieval augmented generation. It was proposed somewhere at the end of the last decade in a paper that was published, and it really transforms how generative AI is being applied in the industry today. So, what is it? Let me just get into that. So, at the core of everything that is generative AI or AI is a model. And in our case, it's a large language model or a multimodal model which generates content, generates text, images, now video and audio too. It can be any model. It can be a small model, a large model, an open source model, a proprietary model, a foundation or a fine-tuned model. But at the core of it is the model. We are all adopters of ChatGPT, I'm sure. So we know that as a user, we say something to the model generates the text or the output or a response. But what we have been discussing as the mismatched reality of the LLM generation is that sometimes it's not true. The model hallucinates, it does not have all the knowledge that we expect it to have, so we can't really use it. But what we saw in the demo also is that if there is information, information that we curate in a knowledge base, and somehow we can fetch the information from this knowledge base and provide it to the model will then generate a response that is relevant, that is accurate, that is contextual, that works for us. Turns out that to do all this, you need a component called a retriever. Retriever, as the name suggests, the responsibility of the retriever is to retrieve information. How that is done is that it accepts the user input or the user's prompt, takes this prompt, goes to the knowledge base, and searches for relevant information. When it has found the relevant information, it fetches this information, passes it on to the model. Uh, no, sorry, before passing it on to the model, this relevant information or context is added to the user input or the prompt in a step that is called augmentation. And finally, this augmented prompt is now passed to the model, and the model then generates the response. And these three components of retrieval, augmentation, and generation give the name to the term retrieval augmented generation. How creative. But the creative use of retrieval augmented generation is that it is being called RAG now. The acronym RAG is very popular. To do all this, to set up a system like this, of course we need this particular pipeline, which is, you know, information retrieval, prompt augmentation, and generation using a model. But another critical step that happens before we set up this generation pipeline is that we have to set up this knowledge base. We have to create this knowledge base like the one that we saw in Yarnit, and that is also a very nuanced exercise. So what I'll do next is I'll go through the steps of creating this knowledge base. And let me take you through the flow. So you have a source, data source, where your information is present. Can be a URL like the one we saw in the demo. We connect to this external data source, can be a data lake, a data object, a URL, a PDF file. We extract information from this document. This part of creating the knowledge base, this particular pipeline, is called data loading. Then, after loading the data and extracting the text from the data, we go through a process of chunking. Chunking is breaking down lengthy pieces of text into smaller, manageable pieces. Why is chunking important? It is important because it really increases the efficiency of retrieval. Imagine searching through a long piece of text versus searching through smaller pieces of text to find out where the information is more relevant. This data splitting component employs several different strategies to chunk the data, and term chunking is very popular. After we have chunked the text, now computers or all electronic devices, they can't run on text. Computers are, of course, mathematical calculators, so they need to process information in form of numbers and not text. So converting this text into numbers is done through a data pattern called embeddings. Embeddings, the discussion around embeddings can be very lengthy, but why embeddings are important is that embeddings help in searching through the data, finding similarity between two pieces of text very easy. And finally, when we have converted the text into embeddings, our final step is to store these embeddings so that they can be used later on when we are going through the actual real-time interaction with the model and the data. It'll hit this storage to retrieve data. And this, in a nutshell, is how we create our knowledge base. Four simple components. You go through these steps and you create your knowledge base. Once your knowledge base is created, you go through the steps of retrieval, augmentation, and generation to really get information that is very relevant and very contextual to you. Simple, novel, but things are not always as you want them to be. So this simple technique of RAG, which is also called a naive approach to RAG or naive RAG, is plagued with some challenges, with some inefficiencies. And these challenges are around retrieval quality, how well you augment this information to create the final prompt for the model, and then, of course, how accurately the model takes this information and generates the results. So when it comes to retrieval, sometimes your knowledge base that you have created is not indexed properly. It is not easy to search through. Your retrieval algorithm itself can be misaligned. Sometimes it would retrieve a lot of information that is irrelevant, and other times it might not uh, retrieve all the information that is relevant. Now, information can come from different sources. So, really, the pieces of text that we have retrieved may be disjointed. They may have repetition. They may have redundancy, which leads to incoherent generation. And the model really fails to incorporate information that it really needs to. Apart from this, at an overall level, uh, this also seems like a one fit all approach. So different type of questions, different type of prompts in this naive rag approach follow the same workflow, which might not always result in the best outcomes. Also, another inefficiency that creeps in to naive rag is this idea of multi-hop reasoning. What multi-hop reasoning means is that if related information is present in two different sources, for example, if I want to answer a question, but the information needed to answer that question is in two different files, then to combine this information and then generate an answer, this naive rag approach um, sometimes fails. Most of the times it does not deliver the results that we expect. So what do we do? That is where we come in. The Yarnit advantage, the contextual engine that we have built, and there are several interventions, several strategies, several techniques apart from on top of this naive rag workflow that we have employed to make this technique better. I will quickly go through a few of the interventions that we have done, and then I'll take you through the entire workflow of how things look like. Let's first talk about the knowledge base creation itself. As I said, there are two distinct components. First, you create the knowledge base, and then the second is your real time interaction pipeline. So, when creating knowledge base, we have sort of a garbage collector which removes irrelevant information, like Megha was saying, from the source data, which results in better retrieval, in lesser hallucinations, in generation, and faster inference, because now you're not processing through the entire data but only the relevant information. So that's one intervention that really enhances the capability of the entire application. The other intervention that we do is optimizing the chunks. So, as we said, large pieces of text need to be broken down into smaller pieces, and but if you just randomly break text in between, chances are that you will lose important information. So what we do is, in our chunk optimization, we try to group information that is related to each other in a single chunk or a single uh, short passage, which again helps in faster retrieval because you have one particular kind of information in one chunk. There is no break in coherence, so your generation will be very coherent. But the most important component of our knowledge base creation, which it really enhances the capability of the entire system, is knowledge graph incorporation. What is a knowledge graph? For those of you who are aware, would know that knowledge graph essentially is is a way to map relationship between different entities. For example, India is a country in the continent Asia, is an information that can be stored in knowledge graph. Or Sachin Tendulkar is a cricketer who played cricket for Indian cricket team. This sort of relationship between entities like Sachin Tendulkar and cricket, Indian cricket team, and Sachin Tendulkar can be stored in a knowledge graph. So you'd understand that when I'm talking about an entity like Sachin Tendulkar, it not only gives me information about who the person is, but also what he did, also the game of cricket, also the Indian cricket team. So, long story short, it helps you in finding those second degree, third degree connections. And what we do is that from the text that is passed to Yarnit, we automatically extract entities and their relationships uh, with each other. So, for example, if you have a product A, who has a customer B, who works in organization C, all of this information is what we extract from the data that is provided from the source. Also, another novel idea behind knowledge graph incorporation is RAG is to create hierarchies where we club similar entities together, similar information together, and create summaries so that whenever the question is asked about different entities, you always have a summary of their relationship that you can use to generate your final uh, content. So knowledge graph really helps in bringing this multi-hop reasoning capability very well. As I said, second, third order information can be extracted, and knowledge graphs are known to be highly scalable. So you can store as much information possible um, in these knowledge graphs that can be used later for retrieval. So now let me walk through the entire process. So what I have here is the knowledge base creation workflow for that we saw in our naive RAG approach, where there is data loading, data chunking, embedding, and vector storage. The interventions that we have brought in, some of them are that we pre-process the loaded data to add metadata, to clean it, to remove confidential information, do a privacy check there. Even when it comes to chunking, rather than simple chunking, we have highly optimized chunking. Our embedding models, some of them we fine tune. I'll not go into details about that, so that our our information that is stored in our vector databases is of high quality. So that's a little bit of enhancement over your traditional vector RAG approach. But what really does make a huge difference is that through this text, we are able to store data in a knowledge graph and then retrieve data from that knowledge graph. How we do it is that the text chunks that we have, we recognize entities from amongst them and find out the relationship amongst these entities and store them in a graph. But not only that, we create communities, graph communities here. The job of the graph communities, or the usage of the graph communities, is to group similar entities together, so that whenever there is questions about multiple entities, you can have summaries that talk about all of that. And your second order, third order connections, your multi-hop reasoning ability can be brought in to your RAG system. So that's on the knowledge base creation that leads to faster and accurate retrieval, deeper context through knowledge graphs, and then very coherent and relevant generation of content. So that's about the knowledge base, how we created, what enhancements we bring on top of the simple RAG approach. Now let me quickly talk about the generation pipeline also. I'll be mindful of time. I think we're good on time. When it comes to generation, which is the real-time information flow that Megha showed when she was generating the blog, right? And you go to the blog, right, and you give an input like, this is the topic of my blog, these are the instructions that I want to give. But all that topic, instructions, all those inputs are not really optimized for retrieving information. The first thing that we do is rewrite the input into a form of a query that can be used to retrieve the relevant and the correct information, so that the retrieval is accurate, it's fast. Then also, what we've also realized that just doing it once might not be comprehensive. We can't convert one input to just one query. So we follow an approach of multiple query retrieval, so that all the information that is necessary is being looked at, and it's not just retrieving part of information that is required, which leads to higher recall of retrieval and a more comprehensive generation. And because we are using graph search, and we also have vector databases, vector storage, where we store embeddings, we employ a hybrid retrieval approach. So it's not just that we are searching in one type of database, but we search through different retrievers. Even when it comes to retrieval algorithm, there is the concept of sparse and dense retrieval, keyword based retrieval. So we employ all of that together, so that all the information is being searched, and again leads to a more comprehensive generation. Uh, and then once the information is generated, we re-rank this information, so that out of all the information that we have retrieved, The most important ones are the ones that rank on top, which leads to higher precision of retrieval. And this is also a foolproofing kind of a system. What if the retriever has retrieved something that is not really relevant? So you apply another layer to again cut out the fluff, so that your most important information remains. And then we employ a technique called prompt compression. Because we have retrieved so much information, there are chances that there is repetition and there is some irrelevance, there are some redundancies. So we just distill the knowledge from all the information that is retrieved, and leads to more relevance, more context, lesser hallucinations. Apart from that, there are also other interventions, like we have uh, a whole library of prompts that we use for augmenting the retrieved information to the original input. We have not just one, but a lot of different models that we employ for generation. In some cases, we have fine tuned the models also. Uh, Even after a response is generated, for example, a blog is generated, how do we ensure that it has actually followed the input that was provided, and it is not generating something that is not useful? We follow the approaches of self consistency and reflection to ensure that the final piece of content that you get is of high quality and does not have irrelevant pieces of text. And finally, there are issues around compliance. There are some guardrails that we might want to put in. For example, if I'm making an advertisement relating to anything in the pharmaceutical or healthcare industry, I can't make any claims. So our compliance checks, our guardrails check for that. But the hero in my eyes, or the most important piece of generation pipeline, is a RAG agent. And one part of that RAG agent is query routing. What does that mean? If I'm generating a blog for a healthcare company versus a social media ad for a retail company, it's not uh, uh, it's not intuitive to think that both of them will follow the same process. And that's exactly what the routing agent at Yarnit does. It takes the input and then makes a decision about what is the generation flow that this input should take. So that is where it makes uh, the whole process really smart and intelligent, which leads to real focus on what we are exactly looking for, the outcome that we want, um, very pertinent to the use cases that we are um, we are going after. And of course that will lead to higher quality with so much nuance that is coming in the entire process. So what does it look like? Again, I will take the foundation of our naive rag and show you how the interventions that we brought in Yarnet make the entire process better. So we again start with you, the user who's inputting a prompt, and the first thing that this prompt encounters is a routing agent. And the routing agent, depending on the input, depending on what is required, directs the workflow in the most suitable uh, uh, path that should be taken. After that, there are techniques like query rewriting, like multi-query generation that I talked about. These are called pre-retrieval techniques, or techniques that are employed before retrieval happens. And there are several others in this particular segment. And after all of this, the input goes to the retriever, and the retriever now itself has changed, because it's not just one method of retrieval, but there are several algorithms in place, and there is a hybrid search that is employed, because there are different kind of databases that we are looking at. And once the information is retrieved, it's not directly passed to the model, but it is first re-ranked, it is compressed in this entire segment of post retrieval techniques. And once this information passes through all the post retrieval strategies, then it is sent to a library which is our augmentation prompt library. So it's not simple as saying, hey, here is the input, here is the information, generate. But there are different techniques for different kinds of inputs and different kind of information that needs to be crafted in uh, in a prompt structure that really helps the model helps to get the best out of the model. It's not even the model is not a single model. There is a model library where there are multiple models, and then the model now generates the response. But that's not the end of it. Now, once the first response is generated, it goes through this entire process of guardrailing and reflection, and the final outcome that comes to you is of really superior quality with a lot of context and very personalized to you. So it will not look like something that you can just generate out of an AI model. It'll be very much a reflection of how you, as a brand or as an individual or as a company, uh, want to showcase yourself, in to the world. Now, this is a very nuanced system that is focused on content generation. But we also wanted to understand, how we like, are we making things better or not? How do we benchmark that? So we went ahead and benchmarked just the graph retrieval part of our approach with other popular vector retrieval approaches, things that are available via LangChain, embedding models that are out there, vector databases that are out there, or even proprietary RAG retrievers like the one that Cohere has or OpenAI's file ranker. And we saw that graph retrieval, even though it's not optimized for question answering in our case, works much better on this particular data set, which is a multi-hop querying assessment data set called Hotpot QA. So there you have it, right? Like it makes the system better, uh, even when we are benchmarking it against different standards. But the overall pursuit that we have of high quality content generation, that is solved through this uh, approach that involves different techniques and different strategies. So, just to recap what I've been blabbering for so long, we all know AI is everywhere, but it is contextual AI that really is something of value. And RAG is a technique that powers contextual AI, but not the naive RAG approach. It might work for some cases, but it's not really the optimal use of the power of language models. So we need to employ knowledge graphs, a lot of pre, post, and retrieval strategies, and really use RAG agents to drive better workflows that will lead to better outcomes. And that's what I wanted to share about what we are doing at Yarnit to really bring alive this promise of contextual AI. Great. Yeah, I'll be happy to take any questions if you guys have or any comments anybody has.
And thank you so much for that, Abhinav. Fantastic. I have so many questions, but I'll probably give a chance for the audience to have their questions first. I see a couple of questions coming in. Um, Let me sort of put that out to you. Why don't you catch a breath?
I'll just have a sip of my cold cup of coffee.
Yeah. Yeah, so I think we see a question coming from Uzair. He's asking which techniques we use to re-rank the extracted data. So Megha, Abhinav, either one of you want to take that?
Realign the extracted data. You mean the ones that we are extracting information from the source data? I'm assuming that. So we employ language models to do that. But they're also, first of all, uh, regular expression matching techniques, and then using language models to really understand what part of the document does not convey a meaning, and then condense information into smaller segments so that you distill a lot of information into the most relevant ones. I think I hope that is what uh, the question meant.
Yeah, yeah, I hope so. Uzair, I hope we answered your question. If you have any further, happy to sort of double down on that and get back to you sooner. Aaron, he has another question for us. He says, Jumbo Genius Abhinav, if we have 1,000 PDFs and we want to ask a query, the responses should provide the contextual answer and attach the specific PDF from a set of 1,000 PDFs. Which vector database would be suitable to handle this task, and how should we approach it? Right?
So I would say that if there are thousands of PDFs that you have, so you have a large knowledge base, no vector database will be able to give a fast retrieval if you're not doing any interventions before storing the data. So first thing is you need to have metadata info. You need to have logical collections that you've put in place. The other very very important aspect is using graph retrieval rag retrieval agents. So depending on the type of query and all the metadata information about your PDFs that you have, a retrieval agent will be able to find out which are these collections that are most relevant to the query that you have been putting in. So even before going into the exact documents or information that you have stored, searching through metadata and finding out where to look is what will lead to better retrieval, faster retrieval, managing the retrieval at scale. But also not just vector databases. Try to do this with knowledge graph. I know, like, storing a lot of information in knowledge graphs is very costly, but try to find out the most important documents out of these thousands that you have, then store in a knowledge graph so that you can extract this information uh, much faster and in a more comprehensive manner whenever it is necessary. But really,
Yeah.
the short
Yeah.
answer is use retrieval agents, have metadata summaries of the collections of the documents that you have.
Yeah, and a lot of that is a function of what use cases you are looking at, right? If you
That's
need to
also
sort of respond to a query in within 10 seconds, 15 seconds, or 60 seconds, it's also a function of that. So we need to, I think, to your question, Aaron, it's also a function of a RAG and vector databases for sure, but it is also about how you orchestrate the entire tech, right? As in, because all of those PDFs need to be extracted, read, uh, passed on, then knowledge has to be retrieved. So it's a and we have spent a lot of time. Maybe we tap onto that. We speak a little bit more about that architecture of ours in some later webinars. But I think there is a genuine amount of play in how we architect it, which is beyond the vector databases alone, right? And of course, the techniques like Abhinav mentioned certainly are of help. Um,
specific question, JD, around which vector database to use. We can go ahead and say that we use
Yeah,
MongoDB.
we definitely use MongoDB because this is something that we have seen working well at scale. And therefore, we, of course, evaluated multiple different vector DBs that are available in the market. But we chose to go with MongoDB because of the scale and the accuracy that we were able to find, and the stability, rather, that
That
we
is
were able
not
to
to
find.
say that is not to say that a Pinecone will not work or some other database will not work,
Yeah.
because I know people are very sensitive these days about making claims about vector DBs. But we use MongoDB because also it acts as our NoSQL store, so makes our life easier from that
Yeah, it was
perspective.
it was it's not an opinion on what is better versus other, because all of these databases uh, are evolving every day. It's an architectural choice that you make. It's a choice of your familiarity that you make often, And in our instances and the use cases that we solve, we just found MongoDB to be more useful uh, than the others, right? As in, so it's not an opinion, certainly, right, on other vector databases available. Folks, I think there is so much question around, how do we evaluate a good rack system? And I know we have had our own journey, right? And then we have tried multiple, frameworks, right? Because as anybody who is building in this space, and of course, a lot of people are building their vector, rack systems, or whether you call that, or you think of a knowledge graph plus rack system. What would be your suggestion, right? As in, how to approach benchmarking, because you also need to know how accurate your systems are working. And I would want to because there is a journey that we also took to get to the right benchmarking technique, right? And we have probably done all of that. So what's your thought on that? And then what are the techniques to use, and how what's the popular available opinion there?
So I would, so there are several, of course, as the RAG is evolving, so are the evaluations. I would also say that the journey of getting the right evaluation for RAG is still in progress. We have not, like RAG, the technique itself is evolving, so is the evaluation. There is essentially a triad of RAG that is proposed by TrueLens. You can go take a look at it. Seems very fair to me. There is this library called Ragas, which is very easy to implement. Comes with its own set of challenges, but it's easy to implement, and a first level of information that you need to get, you can get from there. Then there is this paper around ARIS, ARES, called ARIS, had come out, which is another framework of evaluating RAG pipelines, which really is domain agnostic. So it works very well for if you have uh, RAG systems that deal with different domains. See, the questions that you should be asking are really three questions, right? Am I able to retrieve the right information? Is my system able to do that? Is the response that my LM or my model uh, that that my model is generating, is that response really grounded in the information that is being retrieved? And then finally, is the answer that is being generated, is the final content that is being generated, does it align well with the original input that was prompted to this system? That is, of course, I'm taking an inspiration from the RAG triad that is mentioned in by TrueLens. But that is what the sort of the basic questions around RAG evaluation are. Of course, there are more nuanced questions also, which is how efficient is my RAG system in combining information from multiple sources, right? Like, am I able to really put together, uh, you know, information for documents that are put in different, that don't really, that are not coherent with each other? Am I able to deal with noise? Because we are dealing with unstructured information, there is a lot of noise. So am I able to filter through the noise? Is my system able to filter through the noise? The other important evaluation criteria is, what if I don't get any information? Will my model still hallucinate, or will it tell me that, hey, I don't know, I don't have the information to answer your question, or to conduct your request, carry out your request properly? And there is this other paper that had come out, which is comprehensive RAG benchmark, or CRAG paper, that had come out, and that talks in detail about a lot of these nuances. When it comes to benchmarking, benchmarking has benchmarking is done on tasks that might not really be your use case. So benchmark is really, if you want to compare with how your system performs uh, with respect to other systems on a globally accepted data set, that is where benchmarks are useful. It's really, I mean, in some way it does let you display or showcase uh, the benefit of using your system. But when it comes to actual usage, I don't see benchmarks really important. But what will help there is uh, if you can create metrics that are relevant to your own use cases. Like we are a content generation platform, right? So coherence is a metric for us, which is difficult to measure. But if we can come up with a metric that will evaluate the coherence of our generated output, and we do that, then that is important for our particular use case, right? When you are generating summaries from large pieces of documents, you there are some metrics that you should build for that. So
Right.
those are the really important metrics that you build yourself, keeping your use case in mind. I think I
Yeah.
extended the answer a lot, but it's a
No,
topic
that's
very close
absolutely
to my
fine.
heart.
We have just 4 minutes in the webinar, so I'm trying to sort of close as much as possible. One quick question, and would really appreciate a quick answer here. Look, I think the advantage of any good RAG system, right? Whether it is vector RAG, graph RAG, whatever we are building, is actually a function of data, right? As in how clean is your data, how good we are able to extract that information, how much of that you have seen as a bearing on how accurate we are able to therefore generate content, or how accurately the RAG agents are able to retrieve and then augment and generate. So that's one. And then if what are the processes that we have used in our own tool or in our research uh, to sort of solve for it.
So I would just stop at saying it is very important, and then I let Megha answer the question.
Right. So, like Abhinav said, is very important. The quality of data matters a lot. The completeness of information that you have matters a lot. What we have done is we have used, like I said, mentioned while I was doing the demo, and like Abhinav mentioned, we get the data from whatever the URL or the document that is there. We try to remove all irrelevant information, right? So if it's a URL, you might have ads, you might have navigation, a lot of additional information that's not really relevant to the content that we are trying to create or add to our knowledge chunk. So we try to clean that information and then create intelligent chunks, right, where the information is grouped intelligently, so that it makes sense. So it's not just using a recursive splitter and breaking it into chunks, but also bringing some method into that madness so that all of the chunks that we have, they make sense. And when the LLM reads that information, it has an entire picture of of the content that we are giving it for the generation that we add in the augmented prompt. Yeah.
Right. Right. Thank you so much, folks. Just a couple of last two slides to cover. I'm sure you're following the space. Would love for you folks to try it. Give us more feedback. And of course, we are launching a newsletter next week. So if you're interested in getting some of this information about marketing, about AI, some of these interesting nuggets that we keep sharing, and love learning from the community, please do subscribe to the newsletter. And look, as in it's a Friday, we must give away something, right? And as what we had to do, and how the hardship that Abhinav and Megha had to take building this, it has resulted into a book that Abhinav is writing, and it's certainly a gold mine. I have been closely following that process of how we are learning and writing that book. So it's not only theory; it's a lot of practical application of RAG and how to get there, and use something the real techniques that we have used to create a production-ready system. So, folks, if you are interested, please do buy the book, read it, right? Do share your feedback. And as a part of this, right, as in we are giving a 50% discount as part of Yarnit, do reach out to us, give us a DM, follow us on LinkedIn, and we'll get back to you with the codes, the coupon codes, so that you can use and read it offline. Yeah, thank you so much, folks, for joining in again. And Abhinav, Megha, fantastic. Yeah, we should do more of these sessions. For now, have a good Friday.
Bye bye. Good night, everyone.
Thank you, everybody. Thank you for listening in. Bye bye.